Assalamu alaikum, sir. As from the name, you have known that our project is an autonomous rover that will be giving us the live map of its cruising way. I will be showing you that effective and important feature first.
So you can see when we click the start button, the robot started moving and the map also started to get generated. It's moving by making slight curve because of the vibration and the sliding surface, but it will not be counted as a turn. As it is a hazard detection rover, it has gas sensors. That's why when we are spraying gas in it, it is using a buzzer as a local alert and it is making dots in the map saying gas. It has detected gas. We are testing it with the gas sensor again. You will be noticing that whenever it is making turns, it is saying that I have came this much centimeters from the last turn and I have turned this much degree. So that's something that can be used while we are discovering any incident occurring factory or something. We will be able to know about the obstacles and also which path is safe. We will be able to know. We are testing again from the beginning with the gas. Now we will be uncovering our five-way flame sensor. We've uncovered it, but as it is day, so there are sunlight. So sunlight has IR. That's why the flame sensor detects each way flame in each way. That's why it gets confused. It works fine at night, and the rover makes moves using the IR sensor whenever it sees flames. It comes backward and makes some moves so that it can safely go away from the fire and move further. And also at the same time, it marks in the map that there is flame. In the next, we'll be testing our temperature and humidity sensor. Whenever that detects temperature, for now, temperature greater than 37 degrees Celsius, it marks in the map that this place has got so much heat. This place has threshold crossing temperature. So that's a thing that also can be used when discovering occurred factories. We will be able to know that in that place there is so much heat. So we may guess something has occurred there. I forgot to mention that we are monitoring every sensor data in Blink web app. There we are receiving live sensor data from the ESP32 and sensors, and also we have a display in our rover that shows live sensor data.
Hello everyone. Today we are presenting our project titled Smart Autonomous Chemical Hazard Detection and Mapping Rover. The main idea of our project is to build an autonomous rover that can enter dangerous places, detect hazards and avoid obstacles, and send live information to the user. In situations like factory fires, gas leaks, chemical spills, or unsafe rooms, sending a human first can be risky. A person may not know if there is fire, toxic gas, high temperature, or obstacles inside. So our motivation is to reduce human risk by sending a rover first. The problem we are solving is important because manual inspection in hazardous areas can cause injury, poisoning, or even death. Our rover can move inside the area, collect sensor data, detect danger, and mark hazard locations on a live map. This makes inspection safer, faster, and more informative. This system has many real-world applications also. Rescue teams can use it before entering fire affected or accident areas. Hospital can use it in laboratories, storage rooms, or oxygen related zones. Industries and factories can use it to detect gas leakage, flame, and unsafe temperature. A simplified version can also help the general public for home and storage safety. Now I will explain the core features. The rover can move autonomously using ultrasonic sensor for obstacle detection. It uses a tank chassis with 400 RPM TT motors, which gives better grip and stability than normal wheels. For mapping, it uses a left encoder to estimate distance and an MPU 6050 sensor to estimate turning angle. These help create a live movement map. For hazard detection, the system uses MQ6 gas sensor, DHT22 temperature and humidity sensor, and flame sensor. When gas crosses the threshold, the map marks the location with a yellow dot. When temperature crosses the threshold, it marks the place with a green dot. When flame is detected, the rover marks a red dot, moves slightly backward, and turns away from the flame. The system uses two ESP32 boards. The master ESP32 control movement, mapping, ultrasonic sensors, encoder, and MPU 6050. The slave ESP32 handles hazard sensors, OLED display, buzzer and LEDs, and blink dashboard. They communicate through UART and keeps the sensing and movement task organized. The main components are ESP32 microcontroller, ultrasonic sensor, MPU 6050, encoder, MQ6 gas sensor, flame sensors, DHT22, OLED display, buzzer, LEDs, motor drivers. TT motors, and power supply. These components were selected because they're affordable, available, ESP32 compatible, and suitable for a prototype safety system. For cost and performance, our project is designed to be cost effective. The total cost includes the tank chassis, motors, motor drivers, ESP32 board, sensor battery, voltage regulators, wires, OLED, LEDs, and buzzer. Compared to professional inspection robot, this project is much cheaper. Also, for our required features, there are no cheaper components available that could provide the same performance. For example, the tank chassis cost more than wheels, but it gives better grip and stability. ESP32 is also a good choice because it provides Wi-Fi and enough GPIO pins at low cost. In future, we plan to add a Raspberry Pi and camera. This allows us to use AI-based decision making, such as detecting fire, smoke, objects, or human through image processing. We also plan to add a rubber layer to the tracks for better grip on smooth and rough surfaces. To conclude, our project is low-cost autonomous hazard detection and mapping rover. It can reduce human risk, detect dangerous conditions, avoid obstacles, and show how hazard location on a moves show how hazard location on a life map. Further, we will be showing the working procedure of our project and show how it works, how it senses using sensor, and how it generates the life map. Thank you.
So this is our project. This is our rover, and this has two layers. This is the base layer where the motor drivers and power cables, actually power cables, those go from directly battery to the motor drivers. We know motor driver has two type of wiring. That one plus minus comes from the battery directly, and the logic unit wiring goes from ESP32. So in the base we have hidden those motor drivers and other wiring stuffs. So this is the base. In my phone's image, this is the left motor driver, and in the back this is the right motor driver. So I have wired them directly from the battery, directly from the little battery. This wire, this goes like down, this goes down, and then from motor driver the power goes to the 400 RPM TT motors. This is the base. This is the base structure, and now I'll be explaining the upper structure, what here is, and from which sensor what data goes into input and what is the output. So this is the MQ6, and this is 7. This doesn't work, and we have excluded it from our project, but it is still here. Whatever. This is MQ6. This collects gas data, and that data goes to this ESP, slave ESP, which gives that to this one. And at the same time, that data is shown in this display, and also the map we have made there. When the gas level will be in warning level, there will be a red dot in the map where the gas value is crossing the threshold. And the main part, there are 3 ultrasonic sensors. They are aligned 30 degrees with the middle one, so that we can calculate the right distance and the left distance, and then understand which is closer, in which side we have more distance. Then the rover will move into that side. And this is the fire sensor, 5-way flame sensor actually. This detects IR ray and tells us from which direction in which direction the fire is. And this sends data to the slave ESP, and this slave ESP sends the data to master ESP. Then, if it detects flame at any side of these 5 sides, then it performs some movement and avoids that flame. Then these are 2 ESP. Those are exposed. So these are the 3 LEDs. One is red. That's the highest level, that is danger level. This is warning, and this is for like normal state. And this is the temperature and humidity sensor, which comes in which is used in the graph. When there is temperature crossing 37 degrees, in the graph there are green dots plotted. And this is the battery that powers the motors and motor drivers. And this battery pack powers the 2 ESP32. And we have used this buck converter to reduce the voltage and supply current to the 2 ESP32. So, and here this is a magic part, MPU 3050, which calculates from when the rover is kept like straight. And we have an option in our web that says that to calibrate it, when we press that button, the MPU 6050 registers the rover's position as 90 degree. This is 90 degree. And when it needs to turn to any side, the ESP gives command to ESP reads the data of MPU 3050 and calculates the turning angle. This is how the turns are performed. So that's it.
এটা হচ্ছে আমাদের 5-ওয়ে ফ্লেম সেন্সর। সো এটা যদি আমরা ফায়ার আনি তাহলে এখানে আমাদের রেড বাটন অন হবে, ডিরেকশনও দেখাবে। এখানেও রেড বাটনে লাইট জ্বলবে এবং এই ড্যাশবোর্ডেও আমার ডেটাগুলো দেখাবে। দেন আমাদের আছে DHT22 সেন্সর, ওইটা টেম্পারেচার আর হিউমিডিটি দেখা হয়। এখন যদি এটাকে চেঞ্জ করে দেখাতে চাই তাহলে এখানে আমার যে ডিসপ্লেতে উপরে নিচে হচ্ছে এখানে এখানে 83 থেকে 85 হয়েছে। এখন আছে আমাদের MQ6 আর MQ7, আর এই যে আমাদের স্ক্রিনে দেখা যাচ্ছে টেম্পারেচার আর হিউমিডিটি। জুম করো। দেন আমাদের আছে MQ6 আর MQ7 সেন্সর, যেটা আমাদের মিথেন, দেন কার্বন মনোক্সাইড এগুলো ডিটেক্ট করতে পারবে। সো এখানে যদি আমি একটু দেখি, এই যে এখানে একটু জুম করা আগে, আমি যদি এখানে দিই তাহলে এই যে আমার থ্রেশহোল্ড ভ্যালুর উপরে গেলে এখানে আমার রেড লাইট জ্বলবে, আর এখানেও দেখাবে। এখন এখানে একটু দেখাবো, এখানে এই ড্যাশবোর্ডটায় সেম ডাটা আমার এখানেও ফলো করবে।